Hey there, and welcome to another one of our fantastically fun, fresh, and fact-filled editions of What If. I'm the host of What If, Peter, and today I'll be taking you through, well, if I'm honest, a mix, a medley, a melange of hypothetical situations that might end Earth as we know it in 2026. Yeah. Hold on. I said hypothetical. I'm not saying they're going to happen, but they could happen. Actually, this first video has a quick list of hypothetical disasters, one of which I think could be possible this year. Maybe two. Let's see if you can pick out which ones I'm talking about. What if 2026 wasn't just another year, but the year that everything finally went wrong? Our planet has survived supervolcanoes, ice ages, asteroid strikes, but the clock is always ticking. And if the wrong chain of events hits at the wrong time, 2026 could become the year that humanity never forgets. Nuclear war, rogue AI, a cosmic hit and run. Which disaster will strike first? And which one will we not see coming? Well, strap in, because here are the top 5 ways 2026 could go catastrophically, spectacularly wrong. Magnitude 20 earthquake. A magnitude 20 quake sounds impossible. And it is, unless something enormous slams into Earth. Something like a city-killing, continent-cracking asteroid. This wouldn't just rattle buildings or knock Grandma's photo off the wall. It would rip continents open. You'd feel the ground convulsing for 5 full minutes, and aftershocks would go on for hours. Cities would crumble like sandcastles. Tsunamis would tear across our oceans. Tectonic plates would lurch, and Earth's geography would be transformed. But here's the critical question. Could we possibly see the asteroid coming in time to stop it? AI takeover. Look, we've let AI into everything. Our homes, our hospitals, our governments. But by 2026, the balance between humans and machines could flip overnight. All it takes is one misread signal, one corrupted instruction, and a single glitch explodes into a cascading failure across thousands of connected systems. Suddenly, markets crash, supply chains freeze, hospital systems malfunction, and autonomous machines stop waiting for human input. Not because the robots hate us, but because they've started following their own objectives with zero interest in ours. And if they do turn against us, well, let's be honest. We've taught them everything they know. Global meltdown. Far to the south, Antarctica holds enough ice to rewrite the map of the world. And sitting there like a loaded trap is the Thwaites Glacier, an ice slab the size of Florida, better known as the Doomsday Glacier. If it gives way in 2026, its 25 million cubic kilometers of ice surge into the oceans. Sea levels wouldn't just rise, they'd skyrocket up 70 meters. Cities would flood, fresh water would be poisoned, ancient microbes frozen for thousands or millions of years would suddenly thaw out and re-enter the world. Say goodbye to Miami, Shanghai, Alexandria. This isn't just a flood. It's the largest forced migration in human history and a total rewrite of every coastline on Earth. Global nuclear war. Global tensions can simmer for years, but in 2026, the pot is already shaking. Suddenly, the world's nuclear powers, the US, China, Russia, India, Europe, and North Korea, all decide that the safest option is to fire before someone else does. Missiles streak across continents, counterstrikes launch instantly, and cities, oceans, even space light up with detonations. Before long, nations are nuking satellites, asteroids, the ocean. Someone even suggests Mars, just to be safe. This is no longer warfare, it's a global tantrum with thermonuclear fireworks. But while governments are busy vaporizing the planet, you're trying to survive the next 10 minutes. A nuclear blast hits with 4 punches: blast wave, flash, fireball, and radiation. If you're still alive, you have moments to escape the fallout, and even if you make it, the world that follows will be colder, darker, and far less forgiving. In a nuclear free-for-all, the bomb isn't the finale, it's the opening act. A black hole swallows Earth. Somewhere out in the star-speckled darkness, there are things that make even nuclear weapons look adorable. If 2026 rolls snake eyes, one of these cosmic monsters could wander a little too close. The fun part? A black hole doesn't even need to hit Earth. It just has to pass nearby, and our year is instantly ruined. The side of Earth nearest to the black hole would begin stretching toward it. Our atmosphere would be vacuumed up. Then Earth would be ripped apart in huge chunks. Then comes the main event, spaghettification. Everything that crosses the black hole's event horizon gets stretched into a long, thin noodle of atoms. People, cities, planets, stars. Forget just Earth. Our entire solar system would be doomed. So, will any of this actually happen in 2026? Well, probably not, but something will go wrong. Something always does. But luckily, humanity is really good at 2 things: creating disasters and surviving them. Yeah, not looking good for you. Okay, coming up, we'll take you through the trials of Earth losing oxygen, colliding with the moon, and getting a little too close to a black hole. We'll melt the world's ice, try to dodge Planet X, and swap our sun out with other objects in the universe. But first, let's take a look at this disaster. Now, we here at What If love space, and we talk about it all the time, but kudos to the star of this next story. It had the eyes of the world on it, granted from quite a distance away, but honestly, it's been quite a while since an object in space had the attention of the entire world. I'm talking about 3I Atlas. This is a simulation of what would happen if an interstellar harbinger of doom smashed into Earth. That odd cigar-shaped asteroid is Oumuamua. It's the first interstellar rock on record. Interstellar, which means it came to us from outside the solar system. And the sheer force of a collision with this rock would carve a crater the size of a city, vaporizing everything in its vicinity. But as far as interstellar rocks go, Oumuamua is not the worst. Meet Comet 3I Atlas. While Oumuamua is big, 3I Atlas might be 14 times bigger, which means 14 times the impact, 14 times the crater, 14 times the vaporization, or more. We'll get into the physics of it later. A collision with this rock would release the same kind of energy that a certain other asteroid did 66 million years ago, ending the reign of the dinosaurs and killing nearly everything on Earth. This means that if 3I Atlas struck Earth today, we're talking an extinction level event. Now, To better understand 3I Atlas, let's take another look at Oumuamua. Like I said, Oumuamua was the first object we've ever confirmed to be visiting us from outside of our solar system. Roughly translated from Hawaiian, Oumuamua means a messenger from afar arriving first, which is quite fitting because it's literally from afar arriving first, at least to us Earthlings. And while scientists have theorized about the existence of interstellar visitors for decades, Oumuamua is undeniably from another star system. How do we know? Because it was moving way too fast to be local. You know, like when you live on a street with young kids and some maniac comes driving too fast and blows the stop sign. Plus, it looked weird. Most of the local comets and asteroids in our solar system move about 20 kilometers a second. That's 12 miles a second. That's incredibly fast, but Oumuamua is moving so much faster. When it left the solar system, it moved at 87 kilometers per second, 54 miles per second. Don't worry, it won't actually hit Earth. Ever. Scientists ran the numbers and realized that Oumuamua is not moving into our neighborhood. It came from deep space, cut through our solar system, and it's returning to deep space, which is fine by me because it drives like a maniac. Scientists have named it 1I 2017 U1, giving the object a whole new classification. The number 1 means it's first, and the I stands for interstellar. And though we suspect that there's always one of these objects somewhere in the solar system, we don't find them very often. The potential planet buster 3I Atlas was only discovered in 2025, meaning that's right, it's just the third interstellar object we've ever discovered in the solar system. But what's weird about Oumuamua, besides the fact that it originated from deep space, is that it's shaped like a cigar. People keep saying cigar, but it could also look like a cucumber, a hot dog, a Tootsie Roll, or a belly buster turkey and bacon submarine sandwich. I clearly need to eat lunch. Now, whatever your flavor, we just don't have these long, cylindrical-shaped objects flying around our planetary neighborhood. The asteroids and comets in our solar system are usually potato-shaped, but Oumuamua is 10 times longer than it is wide, and it spins around on multiple axes, which has led to all kinds of speculation and excitement. Some scientists theorize that it may have been made by aliens. Maybe it was a probe or an alien-made ship, like an alien scout on a mission to seek out other life forms. Part of that speculation was driven by Oumuamua's inexplicable acceleration. Yeah, it was moving faster than it should have been. Those same scientists initially suggested it may have been due to an alien light sail, or solar sail, a type of spaceship drive that relies on the force of star radiation. Spaceships with solar sails aren't science fiction. Though they're rare, humans have successfully launched solar sail-powered spacecraft too. Still, most scientists don't agree with the idea that our first verified interstellar visitor is, an alien probe. They studied the interstellar Voyager and concluded that Oumuamua is more likely just a comet that doesn't play by our solar system's usual rules, in that it's never shown one of those famous comet tails. But it's a comet all the same. This means that its extra acceleration is likely due to some kind of hydrogen outgassing. Since it was discovered near Jupiter's orbit, Oumuamua has already shot by Saturn and Neptune and is now headed for the constellation Pegasus. It's been traveling through space for hundreds of millions of years, and it'll be hurtling through the expanse for another 100 million years or more. But that's nothing compared to how long 3I Atlas may have been around. There's a good chance that, as weird and mysterious as Oumuamua was, 3I Atlas could be even more intriguing. First off, 3I Atlas is from a very different part of space than Oumuamua. It looks like 3I Atlas originated in the Milky Way's thick disk of stars, which means there's a high chance that 3I Atlas is older than our solar system. quite possibly billions of years older, born in a region of primeval stars, formed in an ultra-violent era of the galaxy's past. While every object in our solar system is a maximum age of 4.5 billion years, Atlas could easily be 7 billion years old, or more. This may be the oldest object we've ever observed in our solar system. It also means that this space rock has a completely different makeup than any other object we've ever witnessed. For example, scientists think there are high levels of nickel and iron in the gases surrounding the comet, which researchers say is extremely puzzling. I mean, all I know is it's metal, which won't be good news when it plows into Earth at 61 kilometers a second. But hold on, we'll get to the impact in a minute. 3I Atlas also has water and carbon dioxide ice blasting out of it. So unlike Oumuamua, it has that typical coma, the envelope of gas and dust, and the tail associated with most comets. The Hubble Space Telescope picked up a shot of Atlas in July of 2025, showing off that characteristic halo of dust surrounding the comet's icy nucleus. The closer it gets to our Sun, the more distinct and explosive the coma and tail will get. And it's going to get close to the Sun. The good news is it's not going to hit the Earth. At its closest point in December of 2025, 3I Atlas will still be 1.8 astronomical units from our pale blue dot. That's still 270 million kilometers, 170 million miles off base. But on an astronomical scale, it's not that far off. Atlas is still going to pass within Mars's orbit and miss it by just 28 million kilometers, 18 million miles. That's less than a quarter of the distance from Earth to Mars. Now, because this comet is still pretty far, scientists are still working to nail down the exact size of it. NASA determined that it's a minimum of 440 meters in diameter, 1,444 feet, and a maximum of 5.6 kilometers in diameter, 3.5 miles. Of course, here on What If, we like to make things big, so for dramatic purposes, let's theorize to the max. 3I Atlas being 5.6 kilometers wide when it hits us. And for our purposes, we're also going to ignore the widely ignored but titillating hypothesis that 3I Atlas is, an alien probe. If you follow interstellar objects, not follow interstellar objects, but read about interstellar objects, well, you may have come across articles from the same group that proposed that Oumuamua was an alien object. Of course, they're also theorizing that 3I Atlas is an alien spacecraft or a technological artifact. We at What If think about aliens a lot too, but this isn't a mothership module. 3I Atlas is just a really big, ancient comet swinging through our solar system at an incredible speed. And now, to the part of the story you've been waiting on. The impact. Let's say 3I Atlas's angle of approach was slightly different as it entered our solar system. And what if we discovered it too late and it arrived on our celestial doorstep before we could figure out how to nuke something in orbit or enlist Bruce Willis to blow it up? Total mayhem, right? So what if 3I Atlas struck Earth instead of passing by harmlessly? Well, to answer this, we have to go back to the planet buster, Chicxulub. This iconic asteroid struck Earth 66 million years ago. It devastated the planet and completely changed the history of life on Earth. So, spoiler alert, if 3I Atlas hit us, it would not be pretty. Now, 3I Atlas is a massive comet, but it's only about half the size of the 10-kilometer wide Chicxulub. Chicxulub was mostly a carbonaceous asteroid made up of a mix of rock, minerals, metals, and some carbon compounds. 3I Atlas is mostly made of carbon dioxide ices and metal. So let's say they have similar densities, but there's a concerning difference. 3I Atlas is traveling way faster. Chicxulub was moving at about 20 kilometers per second when it hit us. Like I said earlier, 3I Atlas is moving at 61 kilometers per second at its slowest, and it would speed up as it approached the sun. That kind of velocity would be a huge problem for Earth, because the faster an asteroid moves, the deadlier the impact. So even though 3I Atlas is smaller and lighter than Chicxulub, because of its speed, it'd hit Earth with 4.5 times the energy of Chicxulub, and it would do way more damage. 3 simple words, say them with me now. Extinction level event. When Chicxulub hit Earth 66 million years ago, it carved a crater 100 kilometers wide, that's 62 miles wide, and 30 kilometers deep. The blast radius incinerated everything within 1,500 kilometers, causing extremely high tsunamis across the planet and ended 70% of the flora and fauna on Earth. 3I Atlas would hit harder. Yeah, it would punch right through the atmosphere, then slam into Earth's crust in just over 1 second. A superheated core of plasma would cremate everything near the point of impact. A 3I Atlas strike would produce a shockwave thousands of kilometers across whatever ocean or continent it struck. If it struck near a landmass like Chicxulub did, it would create super hurricane-level winds, talking speeds of 1,000 kilometers per hour. These are hurricanes that would destroy forests and cities, and the blast would launch trillions of tons of molten material into the atmosphere. It would burn every tree on the continent and set every forest on the planet on fire. Then cue the tsunamis. High waves would flood the continents, moving 100 kilometers inland. Rubble would fall from the sky, and land would slide into the sea. Everything on the side of the planet that was struck would be toast. After that, the impact would cause worldwide earthquakes that register beyond the Richter scale, volcanic eruptions, and even more tsunamis. And then, after the fires burned out, things would get real quiet, but not in a good way. The immediate effects of the 3I Atlas impact would be devastating, but the real planet killer effects are the long-term consequences. When an asteroid or a comet of that size blasts that much magma, water vapor, silt, and dirt into the atmosphere, it blocks the sunlight. For years, maybe even decades, the sky would go dark, it would get cold, nuclear winter cold, photosynthesis would stop, plants would die, and everything that fed on plants would be gone too. All the debris in the atmosphere would rain down on the Earth as extreme acid rain. Any terrestrial or freshwater vegetation that wasn't already burnt, frozen, or dying from lack of sunlight would fry under this rain. That would add to the collapse of the food chain. So, unless you had a real deep bunker loaded with cases of canned beans, you and every animal that survived the initial disaster starved to death. The planet would also face the destruction of the ozone layer and even toxic metal poisoning from all the material raining back down on it. Now, once that all settled, after a few years, things might actually start to get hot. That's because since Atlas is made of carbon dioxide ice, all that ice would vaporize when the comet hit the ground. But Earth wouldn't heat up right away. Only much later, when the skies finally clear, would the leftover carbon dioxide start trapping heat and push the climate back in the other direction. So first a deep freeze, then a long, scorching recovery. Not that you'd be able to witness any of it, because you wouldn't be alive. In short, if 3I Atlas struck Earth, it would be a global mass extinction. Enormous loss of life, species, entire countries, and continents. I mean, would probably be a good time to be on the International Space Station, though getting back home might be a problem after all the Armageddon. Now, the good news is, like I said, 3I Atlas isn't actually going to come anywhere near us. But it's a little sad because studying this older than the solar system comet up close would be huge. Telescopes on Earth don't have a great angle on it against the sun to be able to study it from a distance. So, you shouldn't look at this comet as a harbinger of doom, but rather an opportunity to look back with time and space before the solar system, our sun, and Earth were even born. Yeah, what a monster that comet is! And it's just the third interstellar object we've ever spotted in our solar system. But with new telescope technology, like the telescope at the Vera Rubin Observatory in Chile, we're estimating that we'll find 15 more in just the next 10 years. This place is fantastic. It sits on the Cerro Pachon in the Andes Mountains, and in just a couple of days after it first got started, well, in a couple of nights, it found over 2,100 new asteroids. 2,100 in our solar system. No big deal, just rocks flying in the sky? Well, get this, 2,100 asteroids is 5 times more than all the astronomers in the world discovered in the last 200 years, since the discovery of the first asteroid, in a few days. It'll be incredible to follow the discoveries coming out of this observatory in the next few years, so we're keeping our eyes peeled. Now, you know what hasn't been observed in our solar system yet? And you better hope it never does? A black hole. A small but incredibly fast, unwanted guest is about to swing past Earth at the speed of light. Yeah, this is the tiniest black hole in the universe. But despite its small size, could it still rip our planet apart? In this video, we're sending black holes through Earth, from the tiniest black hole, just 2 centimeters in diameter, to the most massive, stupendously large black hole. For you, on Earth, things are about to get bad. Okay, black holes come in all sizes. Most of them are called stellar mass black holes because, well, they're born when a massive star, at least 8 times heavier than our sun, collapses and becomes a tiny but very dense black hole. This is Gaia BH1, and it's the closest black hole to us, just 1,560 light years away. This black hole is almost 10 times as massive as our sun, but it's small. Its event horizon is only 59 kilometers wide. That's 37 miles. And we'll send it our way in a minute, but for now, let's talk about black holes that nobody has ever observed before. Yeah, some black holes are incredibly tiny, but to see those, we'd have to go back to the very first moments after the Big Bang, when our universe exploded from a singularity 13.8 billion years ago. This is a time when tiny black holes popped up before any galaxies or planets even had time to form. The scientists call these primordial black holes. We've never observed them to confirm their existence, either because these black holes are too tiny for us to detect or because most of them have evaporated by now. But we theorize that these tiny, dense pockets of gravity existed a long, long time ago. What's interesting about these primordial black holes is that they could be as tiny as 1 femtometer in size. But even then, they'd weigh as much as a mountain. Now, for our story, we'll start with a black hole a bit larger, with the exact same mass as Earth. Of course, Earth didn't exist at the same time as one of these black holes might have, but we here at What If, well, we like to imagine hypothetical scenarios, as you may have noticed. And in this hypothetical, a black hole just as massive as Earth is about to hit us. Only you wouldn't see it coming because it would be tiny. So we'll make it larger just for the sake of visuals, but in reality, a black hole of this mass would have an event horizon of just under 2 centimeters, 3/4 of an inch wide. Smaller than a coin, but with the gravity of our entire planet. It would fly by Earth like a bullet, and it would only take 0.04 seconds to do so. Depending on how close to Earth it passed, this tiny visitor could cause devastating effects. With this much gravity, it would pull on different parts of the Earth with different strengths. The side of the Earth facing it would be stretched more strongly than the far side. These tidal forces would put a lot of strain on Earth's crust. Even if it didn't go through Earth, but just near it, this tiny black hole could set off tsunamis, earthquakes, and volcanoes all over the planet. And worse than that, this black hole would yank Earth out of its usual orbit. Yeah, our planet could go on a wild ride a little closer to the sun. And if it did, Earth would face extreme climate change, and fast. Or we could go the other way and move closer to Mars. Now, if Earth left the habitable zone of our sun, things down here would get very cold very fast. But what if this black hole didn't just pass by Earth, but passed through it? Well, it would be like piercing our planet with an extremely fast and massive needle. The black hole would create a narrow tunnel that would go all the way through our planet. Anything in its vicinity would be stretched and torn by tidal forces, or spaghettified. Massive earthquakes would ripple through the entire planet in seconds. Fault lines on the other side of the world would slip. Entire tectonic plates could shift. This wouldn't be a local earthquake. It'd be the crust cracking everywhere at once. Being on Earth for this would be horrifying, and you wouldn't even know why things were going south, because if you remember, you wouldn't see this black hole coming. When it comes to black holes, size doesn't always matter. It's their mass. So let's move on to a more crushing black hole. A stellar mass black hole, as massive as 10 suns. Okay, despite weighing 10 times more than our sun, it would only be about 59 kilometers wide. That's 37 miles. It's less than the distance you drive in under an hour on the highway. But that tiny shadow packs gravity strong enough to shred planets. From the moment this black hole entered the outer region of our solar system, Kuiper Belt, you'd only have about 5.5 hours until total chaos. In 4 hours and 50 minutes, astronomers would see its effects on Jupiter. Now, while the black hole wouldn't strip gas from the giant planet unless it passed extremely close, well, we might detect unusual gravitational anomalies around it. Jupiter would likely experience tidal disruption if the black hole came close, but luckily for this gas giant, no gas would spiral into its accretion disk. That's because the black hole would be moving too fast for that. Another 30 minutes later, Mars would be dangerously close to the black hole's gravitational grip. Now, Mars wouldn't disappear into the black hole unless it was directly in its path. More likely, it would be torn apart by tidal forces or flung out of its orbit. Suddenly, things would start to feel off. Even without light, the black hole's presence would distort the night sky. Stars might appear to swirl around it. This effect is called gravitational lensing, but you'd need a powerful telescope to see it because this black hole is still pretty small in size. At this point, you'd feel like the ground was shifting underneath you. That's not your imagination. It's Earth slightly stretching toward the black hole as its gravity pulls on one side harder than the other. Seconds later, things would get violent. The planet would crack across continents. Tides would surge violently, not from the wind or the moon's pull, but from pure gravity. Earthquakes would erupt everywhere at once. Everything would be shaking, cracking, and ripping apart. During this violent event, Earth might lose the moon if its orbit became too unstable. But our planet would survive. It'd be stretched and damaged, and it would take a long time to recover, but still, it wouldn't become one with the black hole. Not yet. But it could get worse. If this light-speed traveling thing wasn't just a flyby, but actually on a collision course with our planet, you wouldn't stand a chance of surviving. In an instant, the black hole would rip through our planet like a bullet. Only this is a bullet that weighs as much as 10 suns, and it would be moving at 300,000 kilometers per second, 186,000 miles. The moment it hit us, the crust, the mantle, the core, everything would be pulled inward. The black hole would shred Earth with tidal forces stronger than anything you've ever experienced. And then, just 0.04 seconds later, it would tear out the other side, leaving behind a tunnel of superheated, collapsing matter. Shockwaves would ripple around the globe, oceans would boil, and the atmosphere would ignite. Entire continents would crack and collapse. Earth wouldn't be swallowed whole. It would be ruptured, deformed, and left bleeding debris out into space. And the black hole? It wouldn't even slow down. Okay, now, how about another type of black hole? An intermediate mass one. These monstrosities are far more rare, or at least harder to detect. We've found hundreds of stellar black holes, but only a few solid candidates for intermediate mass black holes. These aren't as small as stellar mass black holes formed from dying stars, and not as enormous as the supermassive giants in the centers of galaxies. These types of black holes weigh between a few hundred and a few 100,000 times the mass of our sun. And scientists think they form when stellar mass black holes collide and merge into a more massive black hole. Now, a black hole 1,000 times more massive than our sun would be catastrophic. Like any other black hole in this scenario, really. Black holes are bad for you if they come too close, and this one would be devastating. Imagine a black hole 1,000 times more massive than our sun rampaging through the solar system. This monstrosity would have a more substantial size, too, packing all its mass into a beast about half the size of Earth. As it came close to Earth, just like all the other black holes on our list, it would start tearing the Earth apart with its enormous gravity. On top of the regular mix of volcanoes, earthquakes, tsunamis, this monstrosity would tug Earth closer, swallowing chunks of it as it passed by. Then, just as suddenly as it appeared, it would pass, leaving Earth with a tilted axis, an unstable orbit, and a civilization collapsing in slow motion. And as always, things would be worse if this intermediate mass black hole were on a direct course through our planet. It wouldn't collide with Earth like a rock. It would just replace the space where Earth used to be, all within a fraction of a second. Earth would start to collapse inward before the black hole even touched our surface. Rocks would lift, and the ground would curve. Time itself starts to come to a standstill near the event horizon. And then comes the breach. The black hole would swallow the planet. Earth would be gone in an instant. Cities wouldn't even have time to burn. They would just stretch and vanish. The black hole would leave a collapsing, molten tunnel through Earth. With the planet's core completely gone, Earth would keep collapsing in on itself, but so fast that you wouldn't even have time to blink. Scary, but that wasn't even the worst of the black holes. Meet Phoenix A star, the baddest, most massive black hole we've ever laid eyes on. This stupendously large black hole has a mass of 100 billion suns. Its event horizon stretches 590 billion kilometers. Just so you can picture the sheer size of this gigantic cosmic death trap, it's 100 times wider than the distance from Pluto to the Sun. Yeah, and it would swallow all planets in our solar system like they were nothing. At first, without warning, strange distortions would appear in the sky. That's gravitational lensing from the most massive black hole in the observable universe. Phoenix A star's titanic gravity would be warping the fabric of space around it. Even before this monstrosity passed through the Kuiper Belt and the outer regions of our solar system, every planet in the neighborhood would feel its galactic presence. Neptune and Uranus would start to drift off their orbits, and a few hours later, the inner planets would get massively disturbed too. Earth's path around the sun would begin to deform under the overwhelming tug of Phoenix A star. By the time you understood what was happening, the flyby would become imminent. Phoenix A star would be approaching Earth at the speed of light. The oceans facing the black hole bulge upward, drawn by its monstrous gravity. Even though the beast would still be unbelievably far out, our tides would grow beyond anything in recorded history. They would flood everything. As Phoenix A star pulled on our planet, the atmosphere wouldn't be able to hold on. Supersonic winds would tear across every continent, and above you, satellites and debris would light up the sky, dragged from orbit like falling stars. Even the International Space Station would plunge into a death spiral it was never built to survive. At its closest pass, Phoenix A star would tear past Earth at the speed of light. For a few seconds, its gravity would overpower the sun's. Earth's orbit would shatter and our planet would be flung out into space. Here on Earth, it would feel as if gravity disappeared for a moment. Everything would lift, people, cars, buildings, and then when it was gone, everything would be caught in a sudden freefall. Now, the Earth's crust couldn't handle such an intense gravitational pull. The planet would erupt in earthquakes and volcanoes, rupturing everywhere. And then, after just 0.04 seconds, just as quickly as it came, Phoenix A star would race onward. In a flash, this immense black disk would start disappearing from view, leaving a distorted star field to gradually return to normal. But the havoc would remain. In its blistering flyby, Phoenix A star would permanently alter the solar system, even our sun. Every piece of rock would be launched out of orbit, ejected on the path to interstellar space. Whatever remained of Earth would become a rogue planet, drifting through space, not bound to any star. In this brief catastrophic encounter, the human toll would be incalculable. Our entire civilization would be left to die. Most coastal cities would become underwater ruins. Inland areas would deal with earthquakes, fires, and storms. It would be the end of the world for you. Even if, by some miracle, pockets of humanity survived the 40 milliseconds of chaos, they'd face an existential challenge adapting to a planet that's drifting toward deep freeze in outer space. So, yeah, black holes suck. They destroy everything they touch, and falling into a black hole, even for a nanosecond, would be lethal for you. There's a needle approaching Earth at the speed of light. A needle? Well, that's no big deal, right? Well, Unfortunately, it's a very big deal. A needle traveling this fast can cause devastating effects on Earth. But why? What kind of destruction could this tiny little needle cause? And in what scenario would this be possible? This is What If, and here's what would happen if a needle hit the Earth at the speed of light. Okay, I'm gonna let you know right away that this is a bad news, good news kind of story, and I'll tell you why in a bit. But first, let me explain to you exactly what the speed of light is. Well, speed of light is how fast light travels. And in empty space, it will always travel at the same speed. No need to worry about drag or wind resistance. And it can travel around the Earth 7.5 times in a single second. If you were traveling at the speed of light, you'd be going very, very, very fast. No surprise there. But just how fast would you be going? Well, let's think about this in terms of one of my favorite trips, a ride to the moon. The moon is 386,400 kilometers away from Earth. And it takes about 3 days or 69 hours for a spacecraft to go from Earth to the moon. But if you're traveling at the speed of light, this trip takes a mere 1.3 seconds. Zip! Why? Well, because you'd be traveling at 300,000 kilometers per second. The fastest human-made object ever made is the NASA Parker Solar Probe, and that only goes a measly 635,000 kilometers per hour. This is pretty fast, but nowhere near light speed. Light speed is the fastest speed that exists in the known universe. Nothing is able to travel faster than the speed of light, which brings us back to the good news part of this scenario. Creating a needle that could travel at the speed of light would be pretty much impossible. But we can look at Einstein's theory of relativity for the answer. According to his theory, as an object's speed gets close to the speed of light, its mass increases. And then, even more mind-boggling, time actually slows down. As the mass of the object increases, it would need more and more energy to speed it up, so it gets harder and harder to push the object to the speed of light. Basically, you'd need to have an infinite amount of energy to make this happen. But let's say an advanced alien civilization has managed to get close to figuring out this physics problem. Instead of 100% of the speed of light, they've engineered a way to make a needle travel at 99.9% of the speed of light. Bam! Take that, Einstein! Okay, but what happens next? Well, you know that a needle is much, much tinier than Earth. If I were to try and tell you how much tinier, it'd be too hard to get all those zeros on the screen, but you get the idea. And because of its enormous speed, it's carrying a huge amount of kinetic energy. Kind of like a bullet. It may be tiny, but it can still do some serious harm because of the speed it's traveling at. So, let's take a look at what happens when this needle hits Earth. What if it landed in the most beautiful spot in New York? Now, I'm not talking about Times Square. I'm talking about Central Park. As the needle hurtled through our atmosphere, there would be an enormous amount of friction generated. Now, we've seen spaceships ignite upon re-entry into Earth's atmosphere because of friction and heat in the air. Well, there's the possibility this needle would begin burning up too and disintegrating due to this enormous friction, but let's assume it keeps going. This fiery little needle would hit the park with a massive explosion. The impact would release a significant amount of energy that would radiate out as heat, light, and a massive shock wave. One estimate calculates that the energy released will be over 100 times the amount of energy from an exploding nuclear bomb. The trees, the grass, the people in the park would be instantly incinerated by the enormous heat of the explosion. The tall buildings surrounding the park and further away in New York City would collapse like falling Jenga towers. Fires would start and everything would start to burn. The explosion itself would create a giant fireball and a shockwave that would pulse out in waves. But the shockwave wouldn't just shake New York City. it would be massive enough to rock nearby states like New Jersey. The ground would shift beneath our feet. The energy released would be equal to the power of an earthquake that's about 7.3 on the Richter scale. We've had one like this before on Earth. In 1906, an earthquake that measured 7.9 on the Richter scale hit San Francisco. It destroyed over 28,000 buildings and killed more than 700 people. Would the impact of the needle on land cause worldwide destruction? Well, there's one scenario in which that might happen, and we'll get to that a little later, but it's also possible that the destruction caused would be limited to the point where the needle strikes and the surrounding areas. So if you're living on the other side of the globe, you might just be lucky enough to avoid the horrific consequences. Okay, so that's what would happen if this needle hit land, and the results are pretty devastating, but what would happen if this light-speed needle plunged into the ocean? Well, the impact would cause a massive amount of water to rise up into the air. The enormous amount of kinetic energy carried by the needle would explode into the ocean, creating a tidal wave. Would it set off a tsunami? Well, like I said, scientists estimate that this needle would give off as much energy as a nuke. That's over 1 megaton of TNT. This would definitely create a big splash. In 1946, in what was known as the Baker test, a 23 kiloton nuke was detonated underwater. This created a plume of water 2 kilometers high. Waves close to the explosion radiated out at heights of up to 30 meters. So our needle would probably cause a gigantic plume of water, but it's unlikely to generate a massive tsunami. That's because the needle would create an explosion at a single point in the water. But for a tsunami to happen, massive shifts in water are needed over vast areas, and that's only created by large geological movements like underwater earthquakes. So the good news is you don't have to worry about a tsunami like the one in the Indian Ocean in 2004, which was equivalent to 23,000 Hiroshima bombs. Yeah, Mother Nature is a whole lot more powerful than this needle. Now, this is what could happen to our planet, but what would happen if this needle hit you? What if it made a direct hit on a human body? This is a scenario where the bad news is infinite, since you'd be the first one absorbing this massive amount of kinetic energy. But the good news is you'd die instantly, so quickly that you probably wouldn't feel it, and you wouldn't have to go through all the devastating consequences that follow for anyone that survives. Now, there's a fourth possibility that could have far-reaching consequences for the entire world. What if the needle landed on the site of an active volcano? If this happened, the impact from the needle would create an opening for a lot of pent-up pressure to be released. It would disrupt the magma underground and set off a series of massive volcanic eruptions. Mass volcanic eruptions like this could cause an extinction event on Earth, just like they've done in Earth's past, over and over again. The Toba eruption 74,000 years ago almost wiped out all human beings. Only 2,000 to 20,000 humans survived that eruption and its aftermath. Volcanic ash thrown high into the atmosphere can linger there for 10 years or longer, blocking the sun. This could create a nuclear winter. With the sun's rays blocked, temperatures drop and crops die out. Would there be any way for humans to survive this catastrophe? It's hard to see how humans could survive 10 years or more with our traditional agricultural systems thrown completely out of whack. As plants die, herbivorous animals will die out and carnivores higher in the food chain will lose their prey. So most animals will go extinct as our ecological chain collapses. But there is a slim ray of hope. Scientists have found that some parts of the southern hemisphere, like Australia and New Zealand, might be able to produce food in these very specific conditions. Conditions without much sunlight and low temperatures. But the grim truth is that these areas wouldn't be able to sustain our current global population of 8 billion people. The vast majority of humans would die out. But a small minority might remain, a group of humans who would hopefully emerge hardier and stronger. I don't know about you, but I'm pretty relieved that the possibility of this tiny needle hitting Earth at light speed is close to zero. For once, I'm happy that we're nowhere near being able to produce an infinite amount of energy, and that we don't know of any advanced aliens with these capabilities either. Thank goodness. Never been a fan of needles, to be honest. I've had a lot of them jammed into me over the years. I'm a blood donor, and as talented as those phlebotomists are at placing the needle in the vein, it can be a bit jarring at first. Although, I got a flu shot a few weeks back, and I gotta tell you, those needles are getting smaller and smaller, thin as a strand of human hair. Anyway, coming up later in the show, you'll see what could happen this year if somehow the moon were to collide with Earth. Guessing that wouldn't turn out well for you. But first, let's take that ball of superheated plasma in the center of our solar system, our sun, and replace it with some other epic, massive objects. What could go wrong? If our sun suddenly turned into a magnetar, we'd all be cooked, and pretty quickly. Magnetars pack about 1.5 times the mass of our sun into an incredibly small space. They're tiny and super dense remnants of ancient stars that have gone supernova, and they have an unimaginably powerful magnetic field. Yeah, this little star would kill everything on Earth, including you. In this video, we'll show you how life would change or end if we replaced our star with some of the most extreme objects in the universe. Some of these, surprisingly, could be better for us than the sun. But before we get into it, we want to hear what object you would want to replace the sun with. Why not tell us your pick in the comments below? Okay, now let's test them all out, starting with a red giant.
Oh my God! Oh dear! Are you filming? Yes, I'm filming!
The bad news is that the sun really will swell up into this kind of red and hot exploding star, and it would swallow Mercury, Venus, and even Earth. The good news is that it'll take 5 billion years to get there, give or take. You see, our sun is what scientists call a G-type yellow dwarf. It's a main sequence star. It runs on fusing hydrogen into helium, but its clock is ticking. The sun formed 4.6 billion years ago. A star like this only has a lifespan of 10 billion years. Only. And when it dies, it goes out with a boom. A red giant kind of boom. But we're not going to be around in 5 billion years to witness the death of the sun. So how about we speed things up and replace our star with the red giant now? Well, because that would mean instant death for you. Because as I mentioned earlier, this red giant would swallow Earth whole. You wouldn't even get a chance to enjoy the view. Immediately, Mercury, Venus, and Earth would be obliterated. And not because this red giant would be so scorching hot. No. The sun's surface burns at 5,772 Kelvin. That's about 5,500 degrees Celsius, or 10,000 degrees Fahrenheit. Red giants burn cooler, mostly because at this point in a star's life, it's burned up all of its hydrogen. This star's surface temperature would be around 3,000 Kelvin. That's just 2,700 Celsius or 4,900 Fahrenheit. But red giants got their name for a good reason. A giant reason, I should say. Yeah, this ball of helium would be 200 times larger than the sun. And it would be anywhere from 1,000 to 5,000 times more luminous. Even if you could look at it just for a second, you'd lose your eyesight. At first, everything would become very bright and orange. The sky would look like it's on fire. You'd be blasted by the most intense heat wave as temperatures on Earth rose by hundreds of degrees. Next, the oceans would boil and disappear. Within minutes, Earth itself would get dragged into the red giant's outer atmosphere. Our planet's crust would melt. All life would burn. The red giant would reach Earth's orbit, blind us, broil us, and then there would be no more Earth left. Gone. Even Mars would get a violent blast of heat. Its carbon dioxide ice caps and permafrost would vaporize instantly, creating a thin atmosphere of gas and steam. It sounds like great news for Mars, but it's not really. Strong solar winds and intense radiation from the expanding red giant would strip away that thin atmosphere in no time. The Martian surface would be hotter than the melting point of lead. All the sand and rock on its surface would melt into a glassy blob. For a short time, Mars would glow like a red-hot coal, but then it would just end up as a dead rock. Other planets further away would be affected too, because the red giant would gradually lose its mass. Its gravitational hold on Jupiter, Saturn, and the other surviving planets would weaken. Any planets that weren't burnt to a crisp would slowly drift away out into outer space. Okay, that was a pretty violent end for Earth. On a scale of how spectacularly we die, I'd rate it a 9 out of 10, taking a point away for not being able to enjoy the view, even briefly. Okay, next, let's go a little easier on Earth and replace the sun with a red dwarf star. Red dwarf stars aren't the same as red giants. These are the most common types of stars in the universe. Most of the exoplanets we find out there in space are orbiting this kind of star. Now, the sun will never become a red dwarf, not even in billions of years, but if it did, well, it wouldn't be so bad. First, it would become really small and dim. Red dwarfs are much cooler than our yellow dwarf sun. Their average surface temperature is about 3,300 Kelvin. That's 3,000 degrees Celsius, 5,500 degrees Fahrenheit. Replacing the sun with this kind of star would cause the skies on Earth to look dark and faintly colored. It'd be like a deep dusk or dawn, even at noon, with a small reddish-orange dot. It's so dim that you could look directly at the red dwarf for a brief moment without any eye damage. But because this new sun would be so dim, temperatures on Earth would start to drop by a lot. Within 1 week, the global surface temperature would fall below minus 18 degrees Celsius. That's 0 Fahrenheit. Within a year, Earth would be about minus 73 degrees Celsius, minus 100 Fahrenheit. The effect of this cooling would take time, but eventually, everything would freeze. The only place left that would still have liquid water would be deep under the oceans. At first, you'd see intense storms and heavy snowfalls, but eventually, the water cycle would stop. There'd be no rain, no snow, no wind, and there wouldn't be enough solar energy for plants to perform photosynthesis. Plants would be the first thing to die out, and soon after, the entire food chain would collapse. In this climate, only the hardiest microbes would have a chance. Some microorganisms deep in the Earth's crust or around hydrothermal vents in the ocean could survive indefinitely, but on the frozen surface, all forms of life would be wiped out. Over the years, the cold would become more intense, and even the near-surface bacteria would go dormant or die. Earth would become a sterile, ice-bound rock. Now, it wouldn't be all that bad because at least you wouldn't die instantly. You might have a chance to leave the planet and travel someplace more pleasant. That is, unless Earth itself took off out of its orbit. Here's the deal with red dwarfs. They're way less massive than the sun, so their gravitational pull in the solar system wouldn't be strong enough to keep all the planets in place. Earth might break off and become a rogue traveler in deep space, getting even colder, darker, and more inhospitable for life. And that would happen fast. Gravity travels at the speed of light, so Earth would start feeling the change as soon as 8 minutes after the sun turned into a red dwarf. Our planet wouldn't immediately shoot off into deep space. No, it would gradually begin drifting away, and then eventually we'd leave the solar system. But at least you'd still have a little time before your imminent death. So, a red dwarf filling in for the sun? Well, I give that a 4 out of 10. Okay, let's move on to something that's not very common in the universe. Turn our sun into a blue star. A blue star. Blue stars might look cold, but they actually run extremely hot. These O-type or B-type main sequence stars are the hottest and most massive stars in the universe. You don't see them very often. O-type blue stars make up only about 0.00003% of stars in our Milky Way galaxy. And our sun physically could never gain enough mass to become a blue star, but if it did, it would look interesting. Daytime on Earth would have an intense, almost stark blue-white glare. The sky would take on a deeper blue or even a violet tint. This blue star would be a lot brighter than the sun. Do not look at it with the naked eye. This bluish light would be overwhelming. Oh, and did I mention it would shower you in extreme levels of radiation? Yeah, blue stars are monstrous. The blue supergiant star, Rigel, emits 60,000 times as much energy as our sun. And some blue stars out there, like Eta Carinae, put out 1 million times the energy of the sun. Even if our new blue sun were a less extreme blue star, Earth would suddenly be receiving hundreds to thousands of times more radiation. If you were exposed to this blue sun just for a few seconds, you'd get an instant sunburn from all the UV radiation. And just as quickly, the Earth's surface would start to heat up. Instead of a global average of 15 degrees Celsius, 60 Fahrenheit, you'd be dealing with temperatures of several hundreds to thousands of degrees. In a matter of days or weeks, Earth would heat up to the point where rocks and metals melt. The oceans would boil away and all life would incinerate. That would be the end of Earth. The good news is that if this blue star had the same mass as the sun, well, nothing else would change in the solar system. Would Mars become a little more habitable? No, but it would become less deadly than Earth for a short time. It would get warmer on the red planet, but the amount of radiation the blue star would bathe Mars in, well, let's just say we wouldn't want to be building habitats there. Blue star? I give it a 5 out of 10. Deadly, but not as dramatic as the red giant. You know, Chase has been dying to go to his star for his next mission, but we're not exactly sure where to send him. What star do you think we should send Chase to? Well, tell us in the comments below. Now, let's see if we can crank it up a notch and turn our sun into a neutron star. Neutron stars are epic. They're born out of a massive explosion called a supernova. It's one of the most violent and energetic events in the universe. The whole blast only lasts about 1 second, but in that second, a star releases 99% of its energy. This mega event can outshine the galaxy for weeks. Of course, there's no way you are surviving this kind of blast, and our sun is way too small to burst into a supernova anyway, so let's skip the initial blast and replace the sun with a neutron star in a more calm way, like this. Within 8 minutes of the last drop of sunlight, the sky would fade to black and stars would appear, even if it were daytime. You wouldn't see the moon or the planets because you can only see them by reflected sunlight. You wouldn't even see the neutron star in the sky. It would be practically invisible to your human eyes. From now on, it's forever night on Earth. And you probably know where this is going. Without sunlight, there'd be no photosynthesis, no plants, no life. Earth would gradually become a frozen rock. But it would be bathed in a different kind of solar energy. Neutron stars are unimaginably energetic, especially if they're pulsars. If this neutron star had a spinning core, that would make its magnetic field stronger. It would become a rotating, magnetized neutron star, or a pulsar. and now you'd be dealing with periodic blasts of intense high-energy radiation. From Earth, these bursts would appear as an aurora-like glowing in the sky. With time, the effects of this radiation would become more intense and cause electronic disruptions, skin burns, and radiation sickness. Life on the surface would be wiped out from two sides, freezing from a lack of solar heating and being irradiated by the neutron star's high energy. Earth would freeze and fry at the same time. But once you zoom out a bit, things would be business as usual. The neutron star would have about the same mass as the Sun, so it wouldn't disrupt the solar system's delicate orbital order. Neutron stars, way too radioactive. They sound epic. I wouldn't want to live close to one, so I'm gonna give it 7 out of 10 on the destruction scale. Okay, next up, let's replace the Sun with a magnetar. Magnetars are extreme. Maybe more extreme than neutron stars. Well, technically, magnetars are neutron stars, just with a little sprinkle of magnetism. And just like neutron stars, magnetars are small, about 20 kilometers or 12 miles across. But their magnetic fields are trillions of times stronger than Earth's. Then here's a bummer. If you expect this kind of view, well, don't, because if the Sun suddenly turned into a magnetar, you wouldn't see anything in the sky. That's because magnetars emit most of their energy in X-rays and gamma rays, not in any visible light you can see. Once again, just like with Jimmy Neutron Star, it would be all night and no moon. And here's another interesting thing about magnetars. These things are burning hot. I mean, all these stars are, but a magnetar's surface temperature is millions of degrees. But on Earth, you wouldn't get all that much heat from one. Again, they radiate their energy as X-rays and gamma rays, not as visible or infrared light that would warm Earth's surface. Plus, a magnetar's surface area is really tiny, so just like in the case of a neutron star, Earth would be blasted by deadly radiation, and it would freeze because of a lack of warming light. But unlike the neutron star, a magnetar would instantly fry our satellites and power grids. Its radiation is way deadlier, and it would also completely disrupt the Earth's magnetic field. A magnetar's intense magnetic field and gamma ray flares would violently compress the Earth's magnetosphere. And you want the Earth to have a stable magnetosphere because that's what holds the atmosphere in place and protects you and me from space radiation. Not only would Earth become technologically blind and deaf, it would also be showered in so much radiation you might turn into the Hulk. Yeah, brother. Ooh. No, not that one. The one who turns green. Yeah, well, that really only works in the Marvel universe. But hey, at least you'd get the view. There'd be incredible auroras in the sky. I was really looking forward to a magnetar. Epic! That's an 8 out of 10. Next up, the scariest and hungriest object in the universe. The black hole. Yeah, remember how I said that some of these extreme objects might be better for Earth than the Sun? Well, scratch that. Nothing is better than the Sun. And a black hole is definitely much worse. To be a little more gentle to our planet, well, let's say that this new black hole in the center of our solar system had the exact same mass as the Sun. Because a supermassive black hole, yeah, that one would just suck you in and not spit you out. But a nice sun-massed black hole wouldn't even disrupt the Earth's orbit. This epic view from Earth. Wait, that's not right. If our sun was turned into a black hole, you wouldn't see a fiery disk in the sky anymore. There'd just be, well, just nothing. That's because a black hole with the same mass as our sun would only be about 6 kilometers, 3.5 miles wide. Bummer, I know. But grab a telescope, you'll see that the space where the sun used to be isn't completely empty. You see, black holes bend light around them, and without the sun's blinding glare, you'd start noticing the stars in the background being smeared into arcs. This effect is called gravitational lensing, and It's really the only way you could see the black hole at all. If some distant star lined up just behind the black hole, you'd see something called an Einstein ring, a perfect circle of starlight wrapped around a pitch black shadow. But like I say, you'd need a telescope to see it. Now, as far as life on Earth goes, well, you and everyone around you would soon freeze to death. Maybe not immediately or overnight, because Earth would still have some internal heat. But after a few years, almost everything at or near the surface will be frozen solid. After millions of years, Earth's equilibrium temperature would get as cold as minus 240 degrees Celsius. That's around 35 Kelvin or minus 400 degrees Fahrenheit. And that's a complete freeze-over. Nothing would survive here. But on the bright side, at least you didn't get sucked into a black hole, so that's a 6 out of 10 for me. Now, you wouldn't notice it at first, but every second, the air around you is thinning, little by little. After 30 seconds, you're gasping. Engines fail, hospitals go dark. By minute 2, planes are crashing, oceans are suffocating, and the sky is turning deadly. If Earth started losing 1% of its oxygen every second, this is exactly how fast the world would end. But how long would it take until we completely run out of oxygen? Can anything survive in a zero-oxygen world? And is there hope for humans to someday repopulate Earth? Okay, so the first few seconds after the oxygen starts disappearing, things wouldn't be so bad. After 10 seconds, there's still 90% as much oxygen as there was before. Maybe you'd get a feeling that the air you were breathing was a little thinner, as if you suddenly decided to hike up Mount Everest. And if you actually ended up on a mountain that high, it would feel even worse. At 5,500 meters, there's already only half the amount of air available as there is at sea level, and now there'd be 10% less oxygen available. So if you were hiking up these heights, you'd be huffing and puffing even more. And if you were an elite athlete, well, your body would be extremely sensitive to changes in the environment. You'd feel exhausted from things that would normally come incredibly easy to you. If you're not in those scenarios, well, maybe you wouldn't be panicking, but there are some people who would. Meteorologists, earth scientists, and anyone monitoring the atmosphere. They would instantly notice the bizarre readings coming in from their instruments. In the time that it takes them to call each other or report an emergency to the government, another 20 seconds would have passed. And going from 21% to 19% oxygen was nothing, but in the next 20 seconds, things are going to get a lot worse. 30 seconds have passed since oxygen levels started dropping, and now 26% of Earth's oxygen is gone. We used to have 21% oxygen in the Earth's atmosphere and 79% nitrogen. Now, with a quarter of the oxygen gone, it only makes up 16% of the atmosphere. What does that mean for you? Well, you definitely notice the difference. You're suddenly gasping for air, taking in bigger lungfuls, and hyperventilating or breathing much faster. You might be standing at sea level on the streets of New York, but your lungs feel like you're on a high-altitude climb. The only folks who might feel okay, well, they're the ones visiting from high-altitude cities like Aspen, Colorado. This city sits at 2,500 meters above sea level. Living at high altitude for years, though, their bodies would have already acclimatized to lower oxygen. So if they're wandering about at sea level, they'd be able to handle the 16% oxygen level. Anyone doing hard labor feels like they have to slow down. Construction workers find sweat pouring down their faces as they try to breathe harder. Factory workers operating heavy machinery might find they're less coordinated and accidents might go up. In hospitals, things might get ugly. Sick people who are already suffering from breathlessness would feel worse. Someone with heart failure, stroke, or arterial damage would already be suffering from a lack of oxygen. Now they'd have even less. Their hearts would beat faster in a desperate attempt to get more oxygen to the body. But this won't work because there's just not enough oxygen available in the air. Because less oxygen is reaching their brain, they'll become confused and some of them will die. And it's not just humans who would be suffering. Birds would start falling out of the sky. Birds depend on the 21% oxygen level in the atmosphere. They have extremely high energy needs, as it takes a lot of power to beat gravity and stay flying in the air. Now, to meet these high energy needs, birds have evolved to extract 25% more oxygen from the air than us mammals. But with the sudden drop in oxygen, they'd run out of energy and would find themselves dropping out of the sky. Well, what about plants? Well, maybe you think they'd be okay, as all they do is take in carbon dioxide and make sugars. But plants breathe in oxygen too, just like us, and they use it to burn food to get energy. The drop in oxygen would force them to use alternative paths to get their energy. Now, maybe all this stress would make you want to have a relaxing campfire, but no luck there. Less oxygen means fires would be sputtering or no longer able to burn. This could also mean that electrical grids would go dark. Without electricity, trains would come to a halt, traffic signals would stop working, emergency signals would start to blare as automated warning systems get activated. After hearing from scientists, governments around the world will have issued the highest levels of security alerts. Cable news anchors will announce the emergency even as they struggle to breathe. Governments may assume that it's a highly coordinated attack on their country until they see that it's happening everywhere around the world. Presidents and prime ministers will get hooked up to oxygen if it's available, but they'll be panicking as they see everyone around them struggling to survive. Out on the roads, people will start yelling and honking their horns. There'll be massive traffic jams on the highways. But why? Well, the standard combustion engine is designed to run using air that has 21% oxygen. With that percentage dropping to 16%, well, the engine can't provide the power that's needed. People will be getting out of their cars, gasping for air, and walking away. Guess we should have bought electric. Oh, it won't just be car engines that are failing. Engines in airplanes won't function properly either. Engines usually compress the air at high altitudes to extract enough oxygen to make the fuel burn. But at this rapidly depleting level of oxygen, there's not enough to help burn the fuel. The seatbelt light comes on, emergency air masks drop for the hyperventilating passengers. Air traffic controllers will see a flood of calls coming in, requesting permission for emergency landing as engines start to fail. Or even worse, planes will start falling from the sky. And it's more than just cars and planes. Anything that uses a combustion engine is in trouble. Powerboats and ships start stalling in open waters. Excavators can't dig the earth, and bulldozers come to a grinding halt. And the problems will only get worse. Okay, you're now a little past 1 minute, and a horrifying 50% of the oxygen in the atmosphere is gone. If you were gasping for breath at the half-minute mark, well, you and everyone else around the world are now feeling a whole lot worse. Everyone is breathing faster now, breaths coming short and shallow. With oxygen concentration in the air down to 11%, humans are fighting to survive. You look at yourself in the mirror and your lips have turned blue. There's so little oxygen reaching your brain that it can't function. Your thinking is warped and your judgment is poor. You want to pick up a phone and dial your loved ones, but you can't make your arms and legs move the way you want them to. You stagger out onto the road. What you see makes you realize the end of the world is here. It's the apocalypse. Emergency sirens are going off with no one to respond. People are staggering or lying unconscious in the street. As you look up into the sky, you see planes falling down toward Earth. The dwindling supply of oxygen has pushed engines to complete failure. 1 minute wasn't long enough for pilots to pull off emergency landings. You crawl back inside to avoid being hit on the head by falling debris. The scarce few patients hooked up to oxygen in hospitals are still breathing, but they see the oxygen levels depleting on their cylinders and they're overcome with fear. The doctors and nurses who tended to them, they're in no shape to look after them anymore. Now, is there any good news in this scenario? Well, forest fires that were smoldering half a minute ago are now completely out. There's not enough oxygen for even hot coals to glow, let alone a forest fire to burn. Now, at this point, there's another change taking place. With less oxygen in the air, well, atmospheric pressure has dropped. Less pressure on the ocean waters means that they start to release dissolved gases. Dissolved oxygen starts to leave the ocean, so there's less for the fish to breathe. This degassing will affect all the ocean's creatures. When the ocean loses oxygen, they'll be struggling to breathe. Ocean creatures breathe oxygen that's dissolved in water, but now that there's less oxygen, they're all gonna die too. Okay, that's what's going on in the oceans, but what's happening up in the sky? Well, the next part of our environment that'll suffer from a drop in oxygen is the stratosphere. Now, the ozone layer is made up of oxygen, where 3 atoms combine to form a single ozone molecule. But a severe drop in oxygen means that the ozone is depleting. And as the ozone gets destroyed, harmful UV rays from the sun will strike Earth. These rays cause cancer and cataracts in humans. Anyone gasping for air on the beach suddenly feels the sun's rays burning into them, even stronger than before. The only good news is that at the rate that the oxygen is disappearing, well, they won't be around to see any of the harmful effects that have happened to their bodies. Okay, another whole minute has passed, and the oxygen level has plummeted even further. Now, 70% of the oxygen in the atmosphere is gone. The concentration in the air has gone from 21% 2 minutes ago to a mere 6%. As the level drops to 6%, humans and animals will begin fainting and falling to the ground unconscious, their faces turned ash-colored. If this 6% oxygen concentration were to last only 4 or 5 minutes, well, there would be some hope for anyone who's still alive to recover. If it lasted 6 minutes, 50% of us would survive. But it's not going to last another second, because every second there's less and less oxygen. Humans, animals, plants, everything is dying everywhere. It's the biggest mass extinction event the Earth has ever seen. Just like 550 million years ago, when a sudden drop in oxygen wiped out 80% of life. Oxygen has disappeared from the deep waters of the ocean, killing off animals that live on the sea floor. The plankton that produce fresh oxygen to replenish our supplies are rapidly dying themselves. The massive infrastructure that humans have built on Earth is crumbling. There's no more electricity being generated from fossil fuels, because burning coal or gas needs oxygen, which is gone. When everything else is dying, weirdly enough, solar and hydroelectricity continue to generate. Water is still flowing, and solar cells don't need oxygen. Earth has clean energy at last, but just with no one to use it. But it gets even worse. This catastrophic event isn't just an exercise in holding your breath. No, this is a complete wipeout of everything on Earth. It's not just oxygen in the atmosphere that's going away. Every molecule of oxygen on Earth is disappearing. That means the oxygen atoms that bind with hydrogen to make water, oxygen that's part of the Earth's crust, and oxygen that's in concrete holding our buildings together. The oceans are becoming a sea of hydrogen as all the oxygen escapes. Earth's crust crumbles into silicon and carbon, and oxygen from concrete disappears. It can no longer bind together, causing all the buildings on Earth to crumble to dust. Okay, 8 minutes after the start of this catastrophe, 99% of the oxygen in the atmosphere will be gone. From 21% of the atmosphere, oxygen now will make up less than 1% of the air, and less than 1% of our bodies, the crust, and the environment. All living things will be dead. It's not just that they can't breathe anymore, their bodies will literally fall apart as oxygen disappears. The human body is 65% oxygen, and along with the buildings, human bodies will become a pulpy mess as oxygen disappears everywhere. There's no coming back from these scenarios. Plants, humans, Earth, everything will be destroyed. Is there any way Earth could recover from this massive 8-minute deoxygenation? No, not if we removed oxygen from every single compound on Earth. Not for billions of years, at least. But let's rewind a little to a slightly less horrific scenario. What if oxygen only disappears from the atmosphere? Could the Earth recover in that scenario? Well, if that's the case, for starters, our buildings would still be standing. Phew. Hello, Colosseum. And some living creatures would have survived, because there are some bacteria that survive without oxygen altogether. The anaerobic bacteria. These were the first ones to emerge on Earth billions of years ago, and with this rapid oxygen depletion, it's almost like we've gone back in time. Conditions are perfect for them to multiply. But what about the rest of life? How about if we flipped a magic switch at this point, so there was a big reversal and Earth gained 1% oxygen every second? Well, in a little under 8 minutes, the Earth would be right back to where we started, 21% oxygen. Unfortunately, there would still be a whole lot of dead people, animals, and dead plant matter everywhere. But wait a minute, let's take a closer look. Not all the animals may be totally dead. There are 2 that have been seen to go without oxygen for quite a while and still live. First are cockroaches. They've been known to live after being submerged in water for up to 40 minutes, so there's a good chance they're coming back to life when we flood the Earth with oxygen again. Then there's the naked mole rat. It can survive up to 18 minutes without oxygen. Now, in addition to these, there's another type of creature that may have survived. It has a useful trait. It can switch back and forth between oxygen-rich and oxygen-deficient environments. Tell you the exact scientific term, they're called facultative anaerobes. If oxygen is available, they breathe like us humans do, but if there's no oxygen, they switch to fermentation. Either way, they survive. So it's possible that Earth would also still have these kicking around. Some bacteria, some yeasts, some fungi, and even some invertebrates in the ocean. One of the aquatic invertebrates with this double survival advantage is a type of segmented worm called a bristleworm. Now, if we waited for life to evolve from anaerobic bacteria, we might have to wait for billions of years. After all, it took 2.5 billion years for humans to evolve from cyanobacteria that first time round. And there's no guarantee that that evolution cycle will take place the second time round. At least not on Earth, which is becoming rapidly more inhospitable. More about that in a minute. A more promising path to humans 2.0 is from the multicellular creatures. Maybe the bristleworms or the naked mole rats, after millions of years of evolutionary cycles, would lead to a second coming of humans. Assuming, of course, that the cockroaches don't take over the Earth. But there's a time constraint. Earth is not going to remain the pleasant place it is right now for billions more years. In a mere 600 million years from now, Earth is going to be a whole lot hotter. The sun will be 6% more luminous, and the amount of solar radiation hitting Earth will go up a lot. If new life forms evolve from what's left, well, they'll have to adapt to survive on a planet that keeps getting hotter. With this heat in 600 million years, there'll be no more photosynthesizing plant life. The intense heat of the sun will drive the removal of carbon dioxide from the atmosphere, making photosynthesis impossible. Then, in another 400 million years, that hot sun will make our oceans evaporate. With no water, it's going to be very hard for even roaches to survive. Well, I'm pretty happy we're not losing 1% oxygen every second. Even if we gain it back, human life on our beautiful blue marble would pretty much be destroyed. And if it's not oxygen yo-yoing back and forth, well, the sun can have a pretty horrific effect on Earth as it ages and heats up more. Yeah, my favorite part of that one, well, toward the end, when the roaches couldn't survive anymore. Hands up those of you who have had roaches in the house before. It's so gross. It's no better if the oxygen level in the air were to increase either. I won't give it away, but again... Okay, how safe are we from satellites? Well, generally we're pretty safe with them up in orbit. The main risk is from falling debris. Do you know that over 200 tons of space hardware re-enters Earth every year? And up to 40% of that makes it through the atmosphere, usually landing in oceans or unpopulated areas. Now, regulations and de-orbiting plans for satellites aims to help minimize debris, but just the sheer number of new satellites, like Starlink, makes this a growing challenge. But what about our oldest satellite and our biggest, the Moon? It's been 150 days since the Moon has been on a collision course headed right toward Earth. As the Moon gets closer, ocean tides are rising, our cities are being flooded and destroyed, volcanoes and earthquakes are erupting around the world. The Moon's gravitational pull is getting stronger and wreaking havoc on our planet. But wait, how did we get here? Well, let's go back. With just 1 year until the Moon hits Earth, we'll take you through each major phase of its approach, detailing the consequences and figuring out if we have any chance at stopping it. T-minus 365 days. Okay, the Moon is ridiculously far away, 384,000 kilometers away. For reference, the circumference of Earth is just over 40,000 kilometers. Well, with this kind of distance, you could fit every planet in our solar system in the space between Earth and the Moon. So this celestial body has a long way to travel, but at this moment, it's headed right for us. At first, you probably wouldn't notice anything. If you were on an ocean beach, maybe you'd find the waves splashing up a little bit higher on the sand, a result of the Moon's gravitational pull on our largest bodies of water. But wait, let's take a second. Why is the position of the Moon so important to us anyway? Well, the Moon plays quite a few essential roles in helping out life on Earth. We'll get to that in a second, but first, why does it stay up in the sky? Well, that's got to do with gravity. The Moon orbits the Earth at a speed of over 1 kilometer per second. That's pretty good velocity, and I'm sure it would love nothing more than to roam freely throughout space. However, since the Earth is so much more massive, Earth's gravity pulls on the Moon, preventing it from being flung out into space. But what does the Moon do for us down here on Earth? Well, one thing it does is help stabilize our climate. More on that later, but if the Moon starts moving toward us, instead of seasons changing, we might get extremely long periods of cold in the Sahara and some extremely hot weather up in Canada. That one I wouldn't mind so much. But what I would mind, our ocean tides changing drastically because of the Moon's shifting. You'll see why soon. Oh, and I forgot to mention, at the speed the Moon is currently moving, it would actually hit our planet in a little under 5 days. So let's slow it down and give us a year in order for us to have enough time to see if we can solve the problem. T-minus 300 days. Okay, the Moon started 384,000 kilometers away from Earth, but now it's 250,000 kilometers away. With the Moon this much closer, it's heavily affecting our oceans. Rising tides are reaching up to 5 meters. This is flooding our coastal cities. Places like New York, Miami, London would all be underwater. Buildings would be destroyed and citizens would be forced to evacuate. But that's not all. Any animals that live on the coasts, like sea turtles and pelicans, would be displaced due to the rising waters. And the salt water from the ocean could leach into our freshwater supplies, leading to contamination. Now, this is only the start, and the moon is getting closer and closer. While we wait for that to happen and cause even more destruction, you might be asking, has this ever happened before? Well, to investigate, we sent our correspondent Rose to find out more.
This whole scenario got me thinking, how do we know that the moon affects our tides so much? Maybe in order to understand that, we need to look at Earth's past first. I'm talking 4.5 billion years ago. Let me show you what I mean. I'm here at Western University to talk to Dr. Gordon Osinski, one of Canada's leading lunar researchers, to get some answers. So, has something like this happened on Earth before?
An object the size of Mars that we now call Theia impacted Earth just after our planet formed. We actually think that this is how the moon formed in the first place. The Earth formed, the other planets of the solar system formed, but also some other planets that no longer exist. And for reasons that we don't know about, one of these, called Theia, came close enough that it hit Earth, and out of this cataclysm, the Earth essentially reformed, and then the moon formed out of the disk that was present around the Earth.
How do we know that they hit Earth in the past? It was so long ago.
One of the biggest bits of evidence that we have is actually thanks to the Apollo mission. Things that we keep learning from the Apollo missions is from the samples that the astronauts brought back. And when geologists first started looking at these samples, they realized that they're really similar to rocks we have on Earth. In some places, sometimes identical. And so this really tells us that the moon and the Earth formed out of the same starting material. And we actually have samples of the moon here on Earth, and actually here in this lab, that we can take a look at, and we'll see that actually, the properties and what these rocks actually look like from the moon is very similar to the rocks we have here on Earth.
Got the gloves on, and we're gonna touch a part of the moon!
This is indeed a sample of the moon. It's not an Apollo sample, but this is a meteorite, and so we actually have quite a lot of meteorites now that have come from the moon from some impact event that kind of ejected them. And you can actually see that in this sample because this is the original outer surface that got a bit weathered in the desert of West Africa. And then we've kind of cut this sample to reveal the inside.
So in a way, the moon is already clashing into the Earth and hitting it, but just in much smaller bite-sized bits.
Absolutely.
T minus 200 days. Okay, the moon is now just 100,000 kilometers away from Earth. Things are only getting worse for our planet and everyone involved. Tides are reaching up to 30 meters high. Every city near the water will be uninhabitable. Infrastructure near these cities will completely collapse. No more subways, trains, all roads and highways will be flooded. Everything.
But why is this happening? Well, I think Dr. Osinski has our answer. What role does the moon play for Earth today?
So the biggest role that the moon plays on Earth is tides. If you've ever gone to the coast anywhere in the world, there'll be a certain level of tide. And if there was no moon, there would be no tides, which is kind of interesting to think about on its own. So the moon essentially asserts a gravitational attraction on the side of it facing the Earth. It essentially is pulling Earth's water towards it.
Let me show you a bit more of what Dr. Osinski means. Peter talks about the tides getting higher, and this is true, but luckily this wouldn't happen all the time. As the moon rotates around the Earth, it creates two bulges around the planet, one on the side facing the moon and one on the opposite. So as the Earth rotates and the moon ends up in different spots, the water bulges in these areas. This creates the rise and fall of tides throughout the day. Now imagine this process being exaggerated to extreme levels.
If we go back billions of years ago and we look at rocks that were formed, in the coastal regions where they were influenced by tides, we do see really dramatic evidence that the tides were substantially higher than they are at the present day. And our explanation for that is because the moon started off much closer to the Earth than it is at the present day.
So it would be the very key role that the moon plays on Earth now that would essentially lead to its own destruction if it came any closer. But luckily for us, that's not happening anytime soon. I've heard that the moon is actually moving away from us about 3.8 centimeters a year, but do we know why it's moving away from us?
When scientists first discovered that the moon was moving away from the Earth, they really didn't have an explanation. But it was actually the development of these, this giant impact hypothesis, this model of Theia impacting Earth and creating the moon. It actually provides a solution, because all of those models suggest that when this event happened, the moon actually formed much, much closer to Earth. And so it fits with the model. The moon started closer to Earth after it formed, and then since then has just been moving outwards, slowly but surely over the last 4.5 billion years.
But don't worry, this won't have any significant effect here on Earth, at least not right away. In about a century, the days will get about 2.3 milliseconds longer, and in millions of years, our ocean tides might get slightly affected. But unfortunately for us, in our scenario, the moon is actually moving towards Earth. So what happens next?
Well, you'd have to go to places with higher elevation. Cities like Denver, Calgary, and Mexico City would all be good bets. They're elevated at least 1,000 meters above sea level, keeping them nice and dry from all the flooding. But that doesn't mean they'd be completely safe. If the flooding from our fast approaching moon doesn't get you, other natural disasters will. T-minus 100 days. Okay, we're now just 100 days from impact, and things are only getting worse. One of the biggest things you'll notice is the changing weather all around the world. Climate patterns may completely shift, causing an increase in hurricanes and violent storms. Now, weather is one thing, but what's even worse? The volcanoes and earthquakes. The moon's gravity exerts force on the Earth's crust, and if it gets closer, well, then the force increases, causing an extreme strain on the Earth's mantle and leading to earthquakes and volcanic eruptions. Under this increased gravitational force, volcanoes could erupt all over the world. The Ring of Fire along the Pacific Ocean would be particularly vulnerable. This area of the world has about 75% of Earth's volcanoes, and it's where 90% of the world's earthquakes take place. And this would only intensify with our approaching moon. With cataclysmic events happening all over the world, everything would be getting destroyed. The cities that were safe from flooding would now be dealing with massive earthquakes and scorching volcanoes. And the moon's collision course with Earth will be happening any day now. Is there any way we could stop it? Well, there actually might be a way. In 2022, NASA ran the Double Asteroid Redirection Test, or DART for short. During this test, NASA intentionally threw a spacecraft at Dimorphos, an asteroid floating around the Sun. The spacecraft successfully pushed the asteroid off course, and now other researchers are building off this initial test. If humans keep digging into this research, it could change everything. Maybe it could even deflect the moon if it were to come after us. But wait, none of that might actually matter, thanks to the Roche limit. This is what would likely happen when our moon approaches Earth. Instead of colliding with us, our planet's gravity would overcome the moon's, causing the moon to disintegrate. T-minus 0 days. Okay, the moon is now just 18,000 kilometers away, which happens to be the approximate distance of the Roche limit. And this is the point where the moon starts to get heavily affected by Earth's gravity. So instead of the moon affecting our gravity here on Earth, our planet is now starting to fight back. Due to the gravitational shift, the moon would start to rupture and break apart into pieces, ranging from tiny dust particles to asteroid-sized rocks. Now, instead of these pieces falling down to Earth and knocking down buildings or impacting the ground like the asteroid that killed the dinosaurs, they would continue to orbit and create a ring around our planet. We'd have frequent meteor showers here on Earth thanks to the sheer volume of asteroids now floating around. And whether through gravitational force or atmospheric conditions, some of these meteors and asteroids would come raining down. Whatever animal life is left on Earth would be left extremely confused. We wouldn't be getting as much light due to the asteroid ring blocking out portions of the sun's rays. This would affect photosynthesis, both in plants and in phytoplankton. Now, less photosynthesis means less oxygen. So any life that did survive would now be dealing with trying to breathe and survive with Earth's decreased oxygen level. And due to this new ring system, there would be so many more shadows cast on the planet. Some places on Earth would be extremely cold. It could get so cold that a global cooling could occur, something that may have happened before. Yeah, over 450 million years ago, a disintegrated asteroid may have formed a ring around the Earth, similar to the one we're seeing right now. Now, this ring around the planet may have led to a global cooling event, one that dropped the temperature of Earth by 8 degrees Celsius. A global cooling like this would cause an extreme shift in temperatures, a shift that would destroy what little food supply humanity has left at this point. And because of all these roaming asteroids and the debris right above us, our communication systems would be down entirely. If anyone else managed to survive this catastrophe, well, good luck contacting them. All satellites would be destroyed, killing our communication infrastructure. With the state that the Earth is in, with all the volcanoes, earthquakes, flooding, global cooling, maybe our best bet is just to leave here. Well, let's assume that we had the spacecraft technology to support that. If we somehow managed to get a spaceship up in the sky, well, we'd be pelted by the thousands of space rocks up in our atmosphere. This ring would be a barrier to traveling, keeping all of Earth's inhabitants inside. Say goodbye to space travel and exploration. And of course, it's safe to say that in a scenario like this, pretty much everyone would die. But this is the relative immediate future. What happens decades later or a century into our new ringed future? Would humanity or Earth ever be able to make a comeback? All right, well, Rose joins us in the studio now to talk a little bit more about the moon crashing into the Earth. Hello, Rose.
Hello, Peter.
You had a nice interview with Dr. O.
Yeah.
He seems to know a lot about rocks, a lot about lunar rocks. What else did you learn in your interview with him?
So basically, my takeaway from this entire video is there's two worst case scenarios, and one is a little better than the other. A, the moon crashes towards Earth super quick and we're all dead. Everyone dies, as you say on What If quite often.
Everyone dies.
Or B, the moon comes towards Earth super slowly, causing more and more havoc as time goes by, which would also screw us over, but not as much as a direct impact would. And in this scenario, the moon would break apart into a bunch of pieces when it reaches the Roche limit, creating a potential ring around the planet.
If we do end up having a ring of moon bits around the Earth and we are still alive to view it, number one, how cool.
Yeah, that'd be so
That'd be
sick.
pretty cool.
That'd be so sick.
Number two, it would be dangerous. How?
We don't know how long it would take for all that moon debris to settle into that ring formation around the equator, right? So eventually, and we don't know how long that would be, it would look like the rings of Saturn, but initially it's gonna be a bunch of debris floating around. It's not gonna go into the equator. It's
right. So it's all rocks all around the Earth.
Exactly.
Killing all our satellites, etc.
Exactly.
And by the time it forms into a ring, it could be tens of thousands,
Yeah,
hundreds of thousands of years.
we don't know how long that would take.
I'm dead.
Exactly. Imagine like having all of these debris floating around Earth would also cause so much havoc on Earth. It would completely change our climate. It could potentially cause another ice age, I would imagine, because if it's blocking out the sun at various times, if super huge debris is moving around and a lot of the sun gets blocked and it creates a disturbance in our atmosphere as well, it would cause such a disruption and all of the ecosystems would have to change or die. So with an ice age happening, debris falling from this ring, how are you surviving this scenario, Peter?
I'm probably not surviving, depending on how many rocks you say are falling down. I don't know, how often and how intense it would be. I would probably dig a bunker underground.
You would dig a bunker?
Well, I'd have somebody dig a bunker for me.
Yeah.
I don't imagine it would save me from, a 1 kilometer wide asteroid that's going to hit Earth.
Yeah.
But at least in the meantime, I can be down there watching my YouTube videos, drinking my light beer, making macaroni and cheese.
I mean, there's a chance humanity could survive if we all lived in bunkers underground for a little bit of what's left of humanity at least. If you could bring only 5 people to live in this bunker you dig with you, who would you bring?
Well, right off the top of my head, my mother, my wife, probably my 2 kids, depend on how they're acting that week. And fifth, my neighbor Tom, because he's very good at survival stuff. What about you?
Yeah.
Do you have 5 people that you would take?
5 people, my parents, my cat, maybe 2 of my best friends. Yeah.
We want to know what you think. So would you rather be killed instantly and painlessly, or possibly painlessly? Or would you like to watch the moon come at you for a year straight, knowing that you're going to die, and then when it hits you, everything changes and you have to work very hard to revive society? For me, it's an easy choice, but maybe you have a different point of view.
Tell us below in the comments.
Regardless of what would happen, it's safe to say that a scenario where the moon falls to Earth is virtually impossible. Remember, the moon is actually moving further away from us every year, and the gravity from Earth pulling it in is just too strong, making sure the moon stays in a stable orbit. And as cool as an asteroid ring around Earth might be, I'd rather keep our oceans and have way less active volcanoes. Underneath Antarctica's ice, there's a deep, dark secret. Today, we're going to melt all that ice to find out how it would transform Earth. What mysteries lie buried deep under its thick, frozen surface? As the ice melts and sea levels rise, what would happen to our coastal cities? And why might this lead to some unexpected diseases? This is What If, and here's what would happen if all Antarctica's ice suddenly melted. Welcome to Antarctica, the continent that encircles the South Pole. It's 40% bigger than Europe and full of ice. Here you'll find seals, whales, penguins, and the odd scientists doing some research. And on this continent, you'll find an ice chunk the size of Florida. Welcome to the 120-kilometer wide Thwaites Glacier. Its more scary nickname is the Doomsday Glacier. When it melts, there will be a catastrophic rise in sea levels all over the world. Now, this Doomsday Glacier is melting incredibly fast. It sheds 50 billion tons of ice into the ocean every year, and it accounts for 4% of the 9 inches of sea level rise that's happened so far. Some scientists are predicting that the whole thing might melt in decades rather than centuries. But we don't even have a few decades to hang around, let alone centuries. So I'm going to show you what happens if it melts a whole lot sooner, in seconds. In just a few seconds, Thwaites has melted and flowed into the Southern Ocean that surrounds it, and from there into the Indian Ocean, the Atlantic, and the Pacific. Sea levels rise by 60 centimeters around the world. The streets of San Francisco are getting flooded. Miami and New Orleans are also rushed with water. But what's going on? Why did this glacier crack and break away from the rest? Well, there's something going on underneath. Beneath Thwaites is a massive river, flowing fast. Melted ice from the iceberg is feeding it. This is happening thanks to geothermal energy from the Earth's molten interior. The melting process starts off slow, but eventually, huge chunks of ice break off. This starts a chain reaction, causing more and more ice to break off and melt. And there's more to it than just one river. A whole world of mysteries lies beneath the ice of Antarctica. But before I take you to that fascinating underworld, I want to tell you about why Antarctica is so important. It's an ice sheet covering an area of 14 million square kilometers, with an average thickness of over 2 kilometers. Just for comparison, that's 1.5 times the area of the United States. That is a staggering amount of ice, 25 million cubic kilometers of it. It's 90% of all the ice on the globe, and locked up in that ice is 60% of Earth's fresh water. Now, unlike the Arctic, where the ice is floating on water, there's land beneath the ice in Antarctica. You don't think about it because 98% of the land is covered with ice. And that's not all. 1.5 million square kilometers of ocean is also hiding underneath this ice. And when all this ice melts in a few minutes, sea levels are going to rise an astounding 70 meters. We'll see what this epic meltdown does to Earth in a bit. But first, I want to show you the bizarre creatures we're discovering inside this frozen landscape. As you explore this uncharted territory, you'll get a peek at the ocean floor, and just above you, you'll see the underside of the ice. Here, you'll find a type of marine life called anemones. These tiny little creatures are burrowed into the underside of the ice. You'll also find some other small fish and crustaceans. The anemones you find are going to be very different from what you'd find normally in the ocean. They're a new species with an unusual trait. See, anemones usually stay rooted to a single spot, kind of like a plant, but these Antarctic anemones wriggle about in the water. Scientists are still figuring out where they're trying to go. Okay, almost nothing grows in that cold darkness, right? So, what are these creatures eating, and how are they surviving? Well, it's probably little bits of plankton and poop ferried in by ocean currents, but they're also eating something that's super weird and kind of gross. It's the ocean equivalent of rotting food in the back of your fridge. These creatures are eating millions of year-old rotting skeletons, bodies, and ancient bacteria that were around when Earth was much warmer. Ooh, watch out! A few more massive glaciers are about to break off. As the neighboring glaciers to Thwaites separate and melt, more water pours into the oceans. Worldwide, sea levels rise another 2.5 meters. Cities on the east coast of the United States are covered in water. Boston, New York, Miami, millions of people are affected. Even as cities are getting submerged, something bizarre would be going on right off the coast of Antarctica. Close by, the sea level would actually be falling as all this ice was melting, while the sea level further away would be rising. Now, why would this strange event be happening? Well, remember, the Antarctic ice sheet is enormous. It weighs a mind-boggling 24 billion megatons. So it exerts its own gravitational pull on the surrounding waters, which raises the sea level nearby. But when the ice melts, the power of that gravity is gone, so sea levels nearby fall, just as they're getting higher elsewhere. Over in the east end of Antarctica, the Denmark and Scots glaciers have melted. This adds another 1.5 meters of water to our oceans. Now, at a 4-meter rise, the United States is now losing national monuments. The Jefferson Memorial is underwater, Fenway Park is submerged, major coastal cities around the world are also flooded. Shanghai, Lagos, Mumbai, Jakarta, ports are flooded and destroyed. All that salty water is flowing into farmland and destroying our crops. Even worse, underground aquifers that give us drinking water are now contaminated with saline spilling over from the ocean. What's scarier is that the contamination runs deeper than just salt. The Antarctic ice carries bacteria that have traits that are dangerous to human beings. Some of these bacteria cause infections, and they're linked to diseases like cystic fibrosis. But it gets worse. They have an even more deadly superpower. They're resistant to the antibiotics we use to treat diseases today. If they exchange parts of their genes with the bacteria of our world, the resistance to drugs will only grow and spread to even more bacteria. At this point, we humans would be toast. We'd no longer be able to fight off bacterial infections. Not good if we're drinking contaminated water. But like any Hollywood villain, these bacteria also have a good side. They can help us create new and better antibiotics. They can help clean up toxic waste sites and maybe even be part of a new biodegradable alternative to plastics. As more and more ice breaks off and melts, other ecological systems are getting thrown out of whack. For one, the melting ice is changing the way ocean currents flow. Before all this ice melted, the water in the oceans moved around in a very particular way. Dense, salty water sank to the bottom of the ocean floor, pushing the less dense water up to the surface. Through this movement, the water acted like a giant conveyor belt, transporting heat and nutrients from one place to another. This is a key factor for the survival of marine life. Now, with fresh water from melting glaciers entering the picture, the water at the ocean's surface becomes less salty and dense and doesn't sink down as far. It's like our ocean conveyor belt has been jammed up. It's no longer able to move heat around from one place to another. Scientists warn that the melting of the Arctic will mess with the warm Gulf Stream. They're still figuring out how an Antarctic ice melt will change our climate. Under some circumstances, for instance, if icebergs broke from the Antarctic and melted further away in the Atlantic, the changes in ocean circulation could bring on an ice age. But if the melting primarily caused sea levels to rise, well, we'd probably just end up with a warmer Earth. And it's not just heat patterns that we need to worry about. Breaking the oceanic conveyor belt means problems with the movement of nutrients from the ocean floor to the surface. These nutrients are important for the growth of phytoplankton, tiny algae at the bottom of the ocean food chain. They may seem small and insignificant, but they're the bedrock of life in the ocean. They provide essential nutrients to marine life. But not all phytoplankton would suffer the same fate. For the phytoplankton around Antarctica's waters, the melting ice would provide iron and give them something rich to feast on. In fact, this event might lead to a temporary massive algae bloom as the waters are flooded with nutrients that were previously buried in the ice. The growth of the phytoplankton might be a good thing because at least they'll absorb a little carbon dioxide. The Earth will need that. Why? Well, because all this ice melting is going to make the planet a lot hotter for several reasons. First, ice helps keep Earth cooler through its super reflective surface. It's very effective at bouncing sunlight away from Earth's surface, which helps keep things cool. But once it's melted, that's a different story. With glaciers melting and the water warming, the activity of microscopic fungi in the water is also picking up. Just like dead leaves decompose in forests, microscopic fungi act on dead matter in the oceans, decomposing it and releasing carbon dioxide. Warmer oceans mean more dead matter gets decomposed, leading to more carbon dioxide being released. Now, on top of this, the melting glaciers create a layer of fresh water on top of the salty ocean water. This causes the oceans to be less efficient at removing carbon dioxide from the air, again, adding to the warming. And now, the rest of Antarctica is breaking up into humongous chunks and melting rapidly. Water from the melting ice pouring into the oceans. As the ice melts, something amazing is revealed. A natural wonder that's been hidden for millions of years. An enormous canyon system, 100 kilometers longer than the Grand Canyon. It's the deepest canyon on Earth, running 3.5 kilometers below sea level and stretching all the way from the interior to the coast. And now you can also see the 15-million-year-old Lake Vostok, the 6th largest lake in the world by volume. And good news, with all the ice melted, you can picnic there. If you're still in the mood to picnic after everything the Earth is going through. Plus, you might want to stay away from the microorganisms living in the waters of Lake Vostok. They've been evolving there, isolated from the influences of our world for 15 million years. Who knows what they could do to your body? But there's no time to admire the canyon or peer at Lake Vostok because sea levels are rising, higher and faster than before. You're witnessing the last and most dangerous stretch. Every last chunk of ice is melted. Sea levels have risen over 70 meters. This rapid rise has caught people by surprise. 40% of the world's population, over 3 billion people, live near a coastline. And vast majority of them have drowned as Antarctica's ice has melted in a matter of minutes. The entire Atlantic seaboard, including huge chunks of the United States, is gone, submerged underwater. People in skyscrapers as high as 23 stories are forced to race to the rooftop in a desperate bid to survive. Parts of California are transformed into bunches of little islands surrounded by water, and other parts of the state are completely gone. London, Paris, Venice, and every major coastal city we know and love is underwater. Millions of people are displaced, injured, or potentially dying from this catastrophic event. Anyone smart enough to jump in their car and flee inland as the water first started pouring onto land may have escaped with their lives if they could get to higher ground, but those are only a lucky few. Governments are in a panic, deploying emergency operations. They know that almost everyone on the coast is drowned, but maybe there's a way to rescue desperate people on top of skyscrapers. But with so many people affected, are there enough helicopters to even rescue these people? Boats would be needed. How will governments be able to replace all the destroyed infrastructure? More importantly, what will we do about the sudden lack of fresh water? With our fresh water mixed with salt water, humans now have a serious lack of drinking water. Suddenly, the land in the interior has become the hottest property. People living in the US Midwest are super happy they were never ever part of the wealthy coastal elite. Denver, Minneapolis, and Las Vegas are looking more attractive than ever before. Now, nations in the southern part of the globe are hit even harder. All of Bangladesh, with a population of 160 million people, is underwater. Geopolitical tensions rise as countries are looking for aid, but since so many places are hit, help is hard to come by. Now that all of the ice is gone, there's still another thing that has to melt: the permafrost. This is the soil that's been frozen at the poles for more than 40,000 years. As it thaws, it releases the carbon dioxide and methane that are trapped underneath it, causing the Earth to warm more and melt even more of the permafrost. As the permafrost thaws, it's as if someone popped a frozen dinner into the microwave. Tiny organisms start to munch on the freshly thawed ancient organic matter. As they do this, they fart out carbon dioxide and methane, which causes global temperatures to rise even more. Great, now we're breathing in microorganism farts and it's getting hotter. Worst scenario ever. Oh, but it can get even worse. In the midst of all this, it's possible that DNA viruses in the permafrost will thaw and kick off a global pandemic. Creating a vaccine in the midst of this catastrophe would be a challenge like never before. Plus, it's hot. Earth is 5 to 10 degrees Celsius warmer. The heat is what's driven the entire ice sheet to melt, but now these changes are making it even hotter. With the average temperature on Earth now almost 27 degrees Celsius, a mass migration of people begins. The most popular spots? Well, Canada, Alaska, and the newly unveiled Arctic and Antarctic regions. These are the new tropical paradises. 34 million years ago, Antarctica was a temperate rainforest like New Zealand. Maybe that's going to happen all over again. Palm trees on the Antarctic coast and alligators swimming in the warm South Ocean. Thank goodness Antarctica is not actually melting in a matter of minutes. With coastal cities turning into watery graves, 3 billion people dead, our groundwater contaminated, more warming on the way, and maybe a global pandemic, I can't think of a worse situation. Okay, quick brain fact. Did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, your brain treats it like active learning, decoding and making sense of new ideas just like it does when you solve a puzzle. So Watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA's spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling, now being brought to streaming for the first time. So, if you ever finish one of these streams and still want more, well, you don't have to wait. You can jump straight into Popular Science and keep that curiosity going. It's there 24/7, ready whenever your brain wants its next aha moment. The solar system. It's no longer about the 8 main planets anymore. Sorry, Pluto. A new planet has entered the fray, and it's hurtling toward Earth. At first, it looks small, but then it starts to get closer and closer. That's when you realize it's bigger than Earth. It's a massive gas giant, just like Jupiter. As this mysterious planet approaches, its magnetosphere will interact with Earth's. This will create a lot of thunderstorms, as well as some beautiful auroras in the sky. But the beauty wouldn't last long. Before you know it, waves would rise high in the ocean, pulled by the new planet's gravitational force. Earthquakes would spread all across Earth. You'd find it harder to breathe as our atmosphere gets pulled away. Because of this new gravitational pull, Earth is breaking apart into chunks. All living things on our planet are enveloped in cold and dark. Life on Earth is over. But wait a second, how did we get here? Could a new planet form in our solar system? Or could it wander in and affect the Earth's orbit? Maybe there's an undiscovered planet already out there. This is What If, and here's what would happen if we discovered a new planet in our solar system. Okay, before we get to any new planets, first let's figure out where our current ones come from. Well, the answer lies in the stars. When a new star is born, it's enveloped in gas and dust. This spins into a donut-shaped disk. Planets start off as minuscule grains of dust, even smaller than the width of a single strand of hair. Hard to believe, I know, but it's true. Due to gravity and other forces, the tiny particles in the spinning disk collide. These collisions can make the dust clump together, first into pebble-sized chunks and then into bigger rocks. These are planetesimals. Now, if we wait a couple more billion years, this is how the planets in our solar system formed. Well, no, not anymore, because after about 3 to 10 million years, solar winds from our sun blew away all the dust and gas used to make new planets. With the gas and dust dispersed into space, there's no chance of forming new planets in our solar system. If we did discover a new planet, it would be one that's already out there. We just need to find it. Well, luckily for us, there's speculation that a new planet might already exist in our solar system. This is Planet 9. Based on scientists' calculations, it may be sitting in the outer regions of our solar system, orbiting our sun. So why didn't we know that this planet exists? Did we just not see it because it's small? No, estimates put Planet 9 at the size of Neptune. with a mass of maybe 10 times that of Earth. We've missed it all this time because of its highly elongated orbit. This has put it at a distance in our solar system that's even further than Pluto. It doesn't really affect Earth. Its orbital path is 400 to 800 times the distance between the Earth and the Sun. And the time it takes for Planet 9 to make a full revolution around the Sun? 10,000 to 20,000 Earth years. Given this massive orbit, well, how did scientists even figure out it exists? Well, they looked closely at the Kuiper Belt. Situated beyond Neptune, this circumstellar disk contains asteroids, comets, and other icy objects. But scientists noticed something weird was going on here. Some of the dwarf planets and icy objects had orbits that clustered together in an unusual way. This could be explained if there was a mystery planet exerting its gravitational force, causing these objects to cluster. Could it be Planet 9? Well, we're not totally sure if it exists. Theoretically it does, but we haven't directly seen it yet. Now, this could change with the construction of the powerful Vera C. Rubin Observatory in Chile. It will be searching the skies. But if a planet can't form, and we're not totally sure about Planet 9, then what are our options for finding a new planet in our solar system? Well, there could be a rogue planet. A rogue planet? Well, isn't that a planet that wears a rakish hat and an eye patch and a leather jacket? Well, not quite. Rogue planets are similar to regular planets, only they're not tied to a star. They first form around a young star, but then they might get kicked out of their solar system. This ejection could happen while different sized objects are whizzing past each other around the star. The heavier planet whizzing by may stay in orbit, throwing a planet with a lower mass out. That's one way a rogue is formed. Another way is when a star formation goes wrong. Maybe the star doesn't ignite and instead becomes a solitary gas giant. How many rogue planets could there be in our Milky Way galaxy? Well, one estimate puts it in the billions, but we don't know for sure. That's because rogue planets are very hard to detect. They give off very little light and at wavelengths incredibly hard to distinguish from background emissions. So, what would happen if one of these rogue planets suddenly entered our solar system? Well, that would depend on a couple of different factors: the velocity of the planet, its size, and its trajectory. Now, we've already looked at what would happen if a Jupiter-sized planet was headed for Earth. That was pretty ugly, but what if, instead of this planet smashing into us, it just wandered close to Earth? Well, that all depends on what we mean by close. If a rogue gas giant the size of Jupiter was wandering even 3 million kilometers away from Earth, well, terrible things would happen. Since Jupiter is 300 times the mass of Earth, it exerts an incredible gravitational force. As the planet got closer, we'd feel the effects of its magnetosphere. It would be filled with charged particles made up of electrons, protons, and tons of radiation. Then it would come for us here on Earth, destroying life on the planet. As this huge planet got even closer, massive tidal waves would rise up, causing catastrophic floods. So, if the radiation hasn't killed us off yet, we'd drown. Then, Earth would crack open. Volcanoes would erupt. Lava everywhere. Apocalyptic stuff. Okay, so note to self, no welcoming any rogue Jupiters into our neighborhood. Not even for a swing by. But forget these gas giants. What about something smaller? Say, an Earth-sized planet that snuck into our solar system. Or a Pluto-sized dwarf planet. Let's explore these options. Well, if either of these planets were on a collision course with Earth, things would get pretty rough. A 100-kilometer wide asteroid that crashes into us would end all life on Earth. And even the dwarf planet Pluto is 2,200 kilometers wide, making a head-on collision with us devastating. Now, if they didn't collide with us and collided with Mars or Venus instead, well, we'd probably get showered with debris from the collision. if the debris is small, and by small I mean less than 1 kilometer wide, humanity would pull through with just some local damage. But a bigger asteroid could have devastating effects. Remember the asteroid that wiped out the dinosaurs 66 million years ago? It was only 10 to 20 kilometers wide. And still, it was goodbye T-Rex and goodbye to most life on Earth. But what are the odds of actually getting hit by a rogue planet? Well, one estimate puts it in the likelihood of less than 1 in 2 trillion within the next 1,000 years. So, what if another planet, Mercury or Earth-sized, swung by close to us? Well, another planet swinging by could produce a similar effect to that of the Moon. It could alter our tidal forces in significant ways. But it all depends on the planet's size, mass, and the distance away from us. Let's say a rogue planet the size of Mercury decided to pass by. Well, Mercury is about 1.5 times the size of our Moon, so its effect on our tides would be stronger than what we see today. But what if it got closer? Well, if it were half the distance of our Moon, it would cause high tides more than 8 times higher than today's. Floods would overwhelm our coastal cities. But that's not all. Mercury would also be exerting a pull on Earth's land, causing earthquakes and volcanoes again. Now, what if it was another Earth passing by? Well, depending on where you were standing, you might see it above you. Then you'd be in an unusual situation. In the middle of 2 equally large masses, each planet would exert an equal pull on you. You'd be in zero gravity. You, as well as most of the other stuff on Earth's surface, would start floating. Fun. The bad news is our atmosphere would float away. Everything would come loose. Ocean, crust, bits of mantle. They'd cause debris to float between the planets, and this debris would begin to orbit the planets too. Both our Earth and the other Earth would lose a lot of energy and slow down. Eventually, they'd collide. Okay, now how about another much more fun possibility? Like, could another Earth jump into our orbit and co-orbit with us? That could be cool. Maybe we'd have another place to call home. Maybe the 2 Earths would share the same circular orbit. But there's another intriguing possibility. Co-orbiting Earths might follow horseshoe orbits. Each planet orbits the Sun in its own horseshoe track, with the 2 half-circles facing each other. While this might sound unlikely, we do observe real-life horseshoe orbits. Saturn's moons, Janus and Epimetheus, follow horseshoe orbits about 150,000 kilometers from the planet. So, in theory, if we had 2 Earths, they could orbit in this horseshoe pattern. Now, how long would it take to travel along our horseshoe and come near our twin? One estimate puts it at about 33 years. And with neither Earth completing a full revolution around the Sun, well, one of us would be in perpetual summer and the other in perpetual winter. I know which one I want to live in. Now, the chance of this happening with a new rogue planet that just wandered by? Probably close to 0, but I gotta say, booking a vacation on another Earth does sound pretty cool. So let's say we discover a new planet inside our solar system, and lucky for us, it's not going to hit any of our planets. Are we safe? What if it's heading for a direct collision with the Sun? Well, then there are 3 possibilities, depending on the crash site and the momentum with which the crash happens. The collision could happen in the outermost layer of the Sun. If a planet the size of Jupiter crashed into the Sun, it would give off an incredible amount of kinetic energy. It could make the Sun brighter for tens of thousands of years. Another possibility is a crash right into the center of the Sun. Now, if this happened, there would be less energy in the outer layer and smaller effects on the Sun's brightness. But here's another scenario. What if, for some reason, rolling Jupiter slowed down as it approached the Sun? Well, then there would be less kinetic energy to transfer. The planet would get shredded. Its core might form a disk around the giant ball of fire, blocking the Sun's light. The amount of sunlight reaching Earth could be reduced by up to 20%. In addition, the amount of the sun's radiation hitting Earth would change. It's unclear whether it would increase or decrease. All depends on the type of disk that forms. Another frightening scenario that could happen: what if a new rogue planet in our solar system shoved Earth out of orbit? If this happened, there are a number of things that could change. With Earth having a new orbital path, our seasons would differ significantly. Maybe we'd experience a new ice age. Or our summers would become scalding hot. The second is a change to our orbital plane, the flat disc-shaped space that all the planets orbit in. Popping out of that plane would mean we'd fall out of step with the other planets. Once this happens, over time, we might get more and more out of sync. Who knows, this might lead to us eventually wandering out of the solar system. Outside of our current orbit, the Earth might take longer to go around the Sun. We might have to add a 13th month to our calendar. Or maybe we just give February a few more days. But a big shove might actually eject us from the solar system altogether. If this happened, well, obviously we'd lose our sun and we'd freeze and die. Or if you were shoved out of orbit and bumped toward the sun, well, things would get pretty hot and we'd fry. I don't know about you, but after looking at all these possibilities, I'm feeling pretty happy that we haven't discovered new planets wandering around in our solar system. Yeah, there's Planet 9, but right now, that's just a mysterious possibility. We're putting up a sign for new planets to stay away. Collisions are catastrophic, near misses are deadly, and pushing us off our orbit would bring on an ice age. Even if a new planet self-annihilates into the sun, it could be a problem. The only possibility I like? Us and another Earth in horseshoe orbits within the Goldilocks zone. Endless summer. I hear it's super unlikely, but if we absolutely have to encounter a rogue planet, I'm holding out for that one.
Planet X? Why not? I can get behind believing in it. Now, to be clear, Planet X, or Planet 9 as it's also named, sorry Pluto, you are no longer the 9th planet in our solar system, has not yet been discovered. But pull out your telescopes, people, because if and when it is discovered, the formal naming rights go to the person who actually discovers it. Yeah, could you imagine naming one of the planets in our solar system? That'd be nuts. I mean, the name still has to be approved by the International Astronomical Union, so you don't name it the Gulf of America or something. Planets are traditionally named for mythological Roman and Greek gods, so there's still some fun names out there. If I found it, I've already decided that I'm going to name it after the Roman marriage deity Mutinus Tutinus, just because I like the name. He's a real thing, look him up. Okay, well, that about wraps it up for today's show. Hope you learned a lot. Hope I didn't scare you too badly. And I hope your 2026 is safe from disaster. Fingers crossed. Anyway, Happy New Year! Hey there, and welcome to another one of our fantastically fun, fresh, and fact-filled editions of What If. I'm the host of What If, Peter, and today I'll be taking you through, well, if I'm honest, a mix, a medley, a mélange of hypothetical